This Mathcast will walk you through the final section and the final lesson in the CPM calculus text, section 12.4, where Taylor polynomials will be used to demonstrate that L'Hopital's rule holds true. In the spirit of mixed-spaced practice, where mathematical ideas recur over long periods of time, often in new contexts, Section 12.4 revisits L'Hopital's rule, which was first introduced in Section 5.5, but this time we'll look at it through the lens of Taylor polynomials, which have been the focus of Chapter 12. Lesson 12.4.1 begins with one final diabolical teacher problem, where your students are challenged to evaluate this limit without a calculator. Now, L'Hopital's rule can be used to evaluate this limit, but it would take 12 iterations in order to reach a conclusion. And that's probably not the most efficient strategy, since the answer turns out to be something as simple as -1/6. So problem 12-111 suggests that a clever way to avoid using L'Hopital's rule is to rewrite the expression for sine of x to the fourth as a Taylor series, and then use algebra to simplify that expression. So problem 12-113, which is the big problem in lesson 12.4.1, involves using Taylor polynomials to demonstrate that, in general, if the limit as x goes to a of f of x over g of x fits the indeterminate form of 0 over 0, then the limit is equivalent to the limit as x goes to a of f prime over g prime, and thereby demonstrating that L'Hopital's rule holds true. You can make this problem momentous by using the red light, green light study team strategy, where after each step, teams must get your approval, your green light, in order to move on. This will afford you an opportunity to check for understanding at numerous stop points, or red lights, and make the most of this final lesson of this course. Now, what happens in this problem is that students will rewrite this limit using generic Taylor series for f and g in the numerator and denominator, letting b sub n represent the coefficients of the series for f, and c sub n represent the coefficients for the series of g. So, since b sub 0 and c sub 0 represent f of a and g of a, which both equal 0 when x goes to a, then this limit can be simplified and factored and then reduced to the limit as x goes to a of f prime over g prime, and this demonstrates that L'Hopital's rule holds true. The rest of class time will be spent on problem 12-114, where students will evaluate a set of indeterminate limits by rewriting them as Taylor series and then simplifying. So this concludes our Mathcast on section 12.4, which is the final section of our CPM calculus text.